Section 11.5, moving into some different things that happen to angles. So far we've talked about central angles and the inscribed arc. Then we talked, or the intercepted arc. Then we've talked about inscribed angles where the vertex was on the circle. This first one, if a tangent and a secant or chord intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of the intercepted arc. Not any different than the other one, where the vertex was on the circle. So this one is just a secant and a tangent, whereas the other one was two secants. Whenever we saw that, it was two secants, or two chords. Okay? So as we see that, we know that that angle is half the measure of the intercepted arc. Same as what we learned the previous day. Okay? This one's a little bit different. So if we have two secants or chords that intersect in the interior of the circle, then the measure of each angle formed is half the sum of the measures of its intercepted arc. So think of it as the average. Okay? I need to find the measure of the angle on the inside. It's not in the center. I know something about its intercepted arcs. So I take the average, add them, and divide by 2. Add them and divide by 2. Okay? Not a big deal. Okay? We'll review in a minute here. Excuse me. Okay, so last one is a tangent and a secant, two tangents or two secants intersect at the exterior of a circle. Then the measure of the angle formed is half the difference of the intercepted arcs. Okay, so 3 different situations, answer the same for each one. 1/2 the difference of the intercepted arcs. Okay, 1/2 the difference of the intercepted arcs. 1/2 the difference of the intercepted arcs. Okay, so if it's on, it's half the intercepted arc. If it's inside and not the center, it's the average, or the 1/2 of the sum. And then if it's outside, it's 1/2 of the difference. 1/2 of the difference. Okay, there's a chart in the notes section. I suggest that if you were absent on the day that we've done these notes, that you get that information from someone else. I do not have it here. Basically what it is it's a little formula sheet for you to do. When it asks where the vertex of the circle is, it's on, in, and out, and what happens and what formulas we use. So you can ask someone else to gather that information. Okay, so the first one, find each measure. We want the measure of angle EFH. Since EFH is inscribed, it's going to be half of the intercepted arc. So the measure of angle EFH is 1/2 of 130, or 65 degrees. Easy peasy, lemon squeezy. Okay, next one. Okay, we want to find the measure of angle EAB. Angle EAB is this one. Believe it or not, this one here is exactly the same measure. So in order to figure out what that is, we're just basically taking the average of the intercepted arcs. So the measure of angle AEB is 1/2 of 139 plus 113. So we add 139 plus 113 and then divide it by 2. So that gives us 252. We're going to take half of that, okay, which gives us 126 degrees. Okay, this one is 126. This one's 126. And funny enough, each of these here is 54 because they have to be supplementary. So once you find one, you can make your way around the circle and find the others if you should need them for another problem. Okay, this one here. Oh, look, it's outside the circle. So if it's outside the circle, it's 1/2 the difference of the intercepted arcs. Okay, so the measure of angle X is 1/2 the difference. So 1/2 of 80. So the measure of angle X is 40 degrees. Okay, the next one, same thing. It's outside, so it's 1/2 the difference of the angles. Okay, so 1/2 of 200 minus 74 gives us 126, and half of 126 gives us 63 degrees. 63 degrees. Okay. All right. Eyeball problem. 2 of the 6 muscles that control eye movement are attached to the eyeball and intersect behind the eye. If the measure of arc AEB is 225, what is the measure of ACB? Okay, so here's A through E to B. It's 225. Well, that's great, Mrs. Herbst. I have one arc measure for an intercepted arc. I don't know the angle, and I don't have the other arc. But I say you do have the other arc, because this arc intersecting in the same place is 360 minus 225. So this angle here for the intercepted arc is 135. Now I have enough to solve the problem. It's 1/2 the difference, 225 minus 135. Okay, that's 1/2 of 90, which gives me 45 degrees for the measure of angle ACB. Okay, I'm going to do this one, and then I'm going to do the other one, only because this one is a little bit easier than the other one. Okay, so if I look at this, I'm looking for LP. Okay, I'm looking for LP. Okay. In this, I need to figure out what PR is in order to find LP. If I can find PR, I can subtract it from 100, which is the measure of LR, and I'm good to go. Okay, so I gave you a hint to find that PR first. Well, I know M to S is 80, but I don't know this one. Okay, so that means that 80, since the angle's on the outside, 80 minus the measure of PR, okay, 1/2 of that has to be equal to 26 degrees. I'm going to multiply everything through by 2. So 80 minus the measure of arc PR has to be equal to 52 degrees. Okay, then I'm going to move the measure of PR. Actually, I'm going to move it so it's positive and move that guy to the other side. So I get 80 minus 52. So the measure of PR is going to be equal to 27 degrees, right? 27. Okay, so that means I have this is 27. I know the whole thing is 100. So the measure of LP is going to be 100 minus 28, or 72 degrees. Okay, that was the easy one, because you only had to find one other thing. But remember that you're always looking, if things intersect or cross, you're looking for multiple different ways to find angles, either inside, outside, or on. Okay, let's take a look at this one. Okay, I need to find the measure of arc YZ. I'm going to put that in red because that's what I'm looking for right here. Okay, so if I take a look at that, I realize that that subtends the same angle that this one does here, UY. Okay, problem is I don't know either of them, but I do know that UY makes 2 secants that deals here with the 68 from W to Z. Okay, I do also know that if this angle is 113, that this one's not far behind, it's at 67 degrees. Okay, so if I take what I know here of the this angle on the inside, it's 1/2 the sum of the intercepted arcs. One of those arcs is 68, the other arc is UY, and that's going to be equal to 67 degrees. Okay, so I'm just going to solve from there. I'm going to multiply both sides by 2. So that gives me 134. So 68 plus the measure of UY is 134. Measure of UY equals 134 minus 68. So you take 134 minus 68, and we get 66. Okay, that should be fairly obvious to us. If we had 66 and 68 and we divide it by 2, we get right in the middle there, 67. Okay, so now that we know that that's 66, we know that the angle on the outside is 49. Okay, so we're going to find YZ. So 1/2, this time it's the difference, so it's the measure of YZ, the bigger one, minus 66. Okay, 1/2 of that is equal to 49. Okay, again, multiplying both sides by 2, not a fan of fractions. The measure of YZ minus 66 equals 98. Measure of YZ equals 98 plus 66. which gives us a measure of 164. Okay, so make sure that you practice those. You know how to do the harder ones, and look at your homework fairly carefully so that you can see how to figure those out and do it correctly.